So what we want to do is test which acne cream is better, A or B. Okay, A or B. 100 teenagers with acne problems were recruited for a study. The response variable was the number of new pimples. So I want to describe number of new pimples. That's what we're going to do.
Pimples is a gross word.
Number of new blemishes. Okay, let's change this to blemishes. Number of new blemishes.
That's so much better.
Oh, I can't find where I am in my notes here. Oh. Nope, I'm not on that day. Okay, here we go. So, describe what you're going to do to design the experiment so a 2-sample t-test would be appropriate. Okay? Now, a 2-sample t-test, what are we going to do? We just need 2 samples. And why would we need 2 samples?
To compare.
To compare, right? To compare what? Okay, the results of both creams.
Can you do a match pairs t-test?
We are not asked to do a match pairs t-test yet. We will.
Can you do that if it's not an experiment?
Okay, but look at B.
Okay, sorry.
We're going to do that in part B. Because what you need to realize is that, you know, this study you can do a matched pairs would be a good idea with the, you know, the way different people's skin reacts to acne treatments. But you could also design it as a 2-sample t-test. So this is a good review of how to design experiments. So you know you have 100 teenagers. So what are you going to do to split them into the 2 samples?
2 groups of 50.
Okay, how are you going to assign them?
Number them 1 to 1.
Mitchell? Randomly. You are going to randomly assign, it's very simple. So I'm going to randomly assign 50 teens to each treatment, A and B. Okay, those are my treatments. Acne cream A, acne cream B. All I'm going to do is randomly assign 50 teens to each treatment. Okay, I don't need to explain how I'm going to randomly assign because I'm not doing a project or anything. That's how I'm going to randomly assign them. And then I'm going to have them use the creams as directed for a specific period of time. Okay, and then I'm going to record and average the results for each group. I mean, it's a simple. What am I going to do to get each group to use the different acne creams? I'm going to randomly split them up. Okay, so 50 teens are in each group. What am I going to have them do? I'm going to have them use the creams for a specified period of time as directed. And then lastly, I'm going to record and average the results. And the results are already up here, the number of new blemishes. That's all you need to, I mean, you could go more in depth, but we're just doing a very basic thing here. So that's how you would do a 2-sample t-test. 2-sample t. Now, how would I design so a matched pairs t-test would be appropriate?
So randomly assign all 100 teams.
You still randomly assign 50 to each one.
Okay, you would still randomly assign 50 to each one, but then what would you do? Okay. No. No. Because a matched pairs, you have to pair them up in a meaningful way.
Their skins have to be like similar.
So can't each teen be their own pair? And so then you could do, well, you could do a before and after well, no, because you're trying to just compare the 2 creams. So could you randomly assign 50 teens to each treatment? Okay. randomly assign 50 teens to each treatment and have them use that treatment for a time. Treatment for a time and record results. Then have each teen use the other treatment for same time as above and record results. Then find differences in results. Difference in results. So this time each teen used one of the treatments to start with. And we made it a good experiment by randomly assigning the first one that they used. Okay? So then, after they used that treatment for a time, we recorded the results. Now, maybe it's a good idea to have some wait time. Then you made each teen wait a while. Then they used the other treatment. So if they used treatment A already, now they're going to use treatment B for a time, and then at the end of using that treatment, record the results. So then you'd have, you'd have teen 1. Okay, so teen 1, let's say they use A first and they get, the number of new pimples is 3, and then they use B and the number of new pimples is 5. And so then we find that difference, so the difference would be -2. And then we average all those differences. So a negative difference in this case, well, it means that B is worse, right? Because the higher your number of new pimples is, the worse the acne cream was, right? Okay. Now, are there other ways to do this? Yes. You could pair the subjects up to start with. You could, have them all see a dermatologist and pair them up by their skin conditions. There's different types of acne. So some of it's in different places on their face. So you'd pair the teens up that are very similar, and then you'd randomly assign them to use A or B. So whichever one uses A, the other one would use B, and then record their number of new pimples at the end and subtract those. So you could make 50 pairs, you could make 100 pairs. There's different ways to do matched pairs. All right, you could also do, each person uses both treatments on sides of their face, and you just randomize which side of the face they use A or B on.
Yeah, this will not really work unless you put a month in between the two
Because
treatments.
it's gonna be impacting the other one.
Oh, yeah, well, that's fine, and, companies are willing to do that kind of thing. Things take a long time for research, so it would work. But there's other options too, just realize that. All right, which method will be the best, do you think?
The second one is more competitive.
Yeah, the first one you get quicker results, but the second one would actually be more thorough.
Okay. Okay, so the first is quicker.
Cheaper. Yeah, and probably.
Quicker and cheaper, okay? But second is what? More thorough?
Yeah.
How do you spell that word? More what? More, okay.
Oh, less variability.
More accurate, okay, due to less variability. Very good. Okay. All right, so let's move on to the next page. Now we're actually going to do a matched pairs test here. Actually, we're going to do a confidence interval. We could do a matched pairs test. Okay. If you're ever asked to decide something, you can do a test or a confidence interval if they just say decide which is better, or unless they say test this hypothesis, then you better do a hypothesis test. So, new homes often come with energy guarantees. That is, the builder guarantees that the cost of heating and cooling the house will be below a certain cost. When there is a complaint, the builder will estimate the insulating power of the house by taking temperature measurements inside and outside the house at randomly selected locations. For example, such as inside and outside of a particular window. Use a 95% confidence interval to estimate the average difference in temperature inside and outside the following house. Okay, so basically location 1, inside was 72.1, outside was 48.6. Now, would you expect there to be a difference in the inside and outside temperature?
Yes.
You would. If the insulation is working, you would expect a difference, right? But you would, if you're checking all the different locations, wouldn't you expect that difference to always be about the same? And you realize that in outside some parts of your house, the temperature is different. Why would the temperature be different outside your house? The sun, the shade, that kind of thing, okay? So there are subtle differences. So now notice, here's a place, I noticed this thing kind of stands out here. 61.2 degrees inside, okay? And that's really different from all these other temperatures, isn't it? Yeah, so this place, maybe bad insulation, there's something wrong. Maybe it's a door that has a leak underneath it, you know, something like that. So that kind of stands out to me. So what we're going to do our 4-step procedure for a confidence interval, but we're going to do a matched pairs. This is going to be a matched pairs. Matched pairs, this is going to be, we're going to do 90%, or 95% matched pairs confidence interval. So 95% matched pairs confidence interval for the mean difference. Okay, matched pairs is never for two, it's not a two sample. You are going to find the difference, inside minus outside. You're going to need to make a new column and find that difference. Okay, so can you do this on your calculator easily? Yes, you can. So, turn your calculator on. I have my observed difference, mean difference, is 20.7. The standard deviation of the difference is 4.04. And that's from entering this in a list 1, list 2, in the heading of list 3, you're going to type in list 1 minus list 2. And then you do one variable stats for this list right here. Okay, so at first glance, well, let's see. No, what are we trying to estimate? This is a confidence interval, so step 1. What are we trying to estimate? Okay, so far we've done step 1. What we're trying to estimate is the difference in temperatures inside and outside our house. Our best guess is the mean difference of 20.7, but it's likely incorrect because of sampling variability, so we're doing a 95% match pairs t-interval for the mean difference. We checked our conditions. Our concern right now is that normal probability plot is a little weird. This is roughly linear in here, but this one is kind of an outlier. So maybe we want to proceed with caution. That's okay. All right, and we already kind of discussed what this means in the context of the problem. It means that maybe at that location there's a bigger difference. The insulation isn't working at that one location. All right, so now our confidence interval, our formula is our mean difference. Our sample mean difference, plus or minus my t critical value, and then the standard deviation of the difference divided by the square root of n of the difference. So now we just plug in our numbers. All right, so we plug the numbers in. So we've got 20.7 here, plus or minus 2.447 times 4.04 divided by the square root of 7. That gives us 20.7 plus and minus 3.74. And then we're just going to add and subtract that. Okay, so that is we're 95% confident that the mean difference in temperature between the inside and outside of the house is between 17 and 24 degrees. Which isn't that big of a range if you think about it. It's really only a 7-degree difference. Do you think that maybe it should be more of a difference?